Hello, welcome back. This week we will continue on project planning, the second topic, project estimation. Last week we were already talking about the project scheduling. So project estimation is to estimate the resource cost and the schedule. We already discussed the schedule, so we'll focus on the resource and the cost. So in order to do that, we need to have some historical information. Then based on the data we already have, then we can make a prediction. But sometimes the information we have is quite limited and it's not in a quantitative way, but we still, make commitment to making good prediction based on whatever information we have. Sometimes we use the expert estimate when we don't have information at all. Then the expert can, based on their experience, they can give a rough estimate how much the project will cost. So just talking about the ways we can do the cost estimation. The first one is a static approach, and this one is the one of the most common used because this only involve product size. We don't consider other aspect. Yeah, like the time is not involved, only the size. So the logic behind is the larger the size, and of course the more cost of the software. And the second approach involve, compared with the first approach, we consider time factor, and also we are including the product size. So this will be, usually we have during the estimating phase, in the initial phase, and then when we have more information, and then so here we have during the Okay, the next approach is using the expert judgment. So we'll use this approach when we don't have much information. The next one is the opposite to the expert, is when you have the historical information, then you can have this algorithmic or empirical model. You have an equation to show the relationship of the cost and the metrics you have. The next one is a process-based estimation. This one is very much like your lab. You're actually using the process base. So you have a break down the whole project into the task, and then you make estimation. You assign a task to different people, and then we can add up the all cost, and that will become the project cost. So this process-based estimation is actually very accurate. The next one is using the machine learning. This one is when you have a lot of data, so that you can apply the machine learning technique to learn the relationship between the project attribute and the cost. This one can also be very accurate, but here the requirement here is you must have a lot of data to learn from. Let's move on. The first one, the expert judgment based estimation. This one, as I mentioned, when you don't have information, when you don't have much information, and then you can invite several experts to estimate. So here you can have three different estimate, the most pessimistic estimate, most likely, the most optimistic estimate. Then you can have the weighted average to get the estimate. So this one way. There's another way. When you have a group of experts together, some aspect can be very strong and will influence the others. So to avoid that conflict, we can apply this Delphi technique. So you still have a group of experts, but they make secret guesses. So this will avoid someone very persuasive and influence the whole thing, and his idea dominate the discussion. So you don't want that happen. So that you will allow everyone to have a fair estimate on their own. And then these guesses are used to compute the group average, and the average is presented to the group, and then a group once again make the secret guesses. Uh, Individual guesses are again averaged. If this is a new average and the previous average is the same, then we use this average. If it's not the same, we go back to do we go back to do the secret guesses again. So this we have this recursive until everyone come to an agreement. So this Delphi technique is widely used, expert judgment based. The next one is process based. As I mentioned, your lab is actually using this estimate. So here you have activities. You have activities, and then for each activity you assign engineer to the task, and then based on the average salary, or based on the salary of each engineer, then you can have the cost of each task. Then you add them up, become the total the total cost of the project. So here is an example, the process-based estimate. So here you have the functionality. So here you break it down by two dimensions, the productivity and the different phases. And each number here is a number is a is a person months. So that's what we use to calculate the cost. So when we calculate the cost, we are not actually using the dollar value. We use the person months, because this by using the person months is more generic. So we eliminate the when you're working in India, the cost is different than working in the United States. The cost will be higher. So we eliminate this. The location, the different attribute. So we only consider it doesn't matter where you are. You're still working for the same task. You need to half a month or 1 week to finish. So it doesn't matter where you are. You still need this many person. So here, by using the person months instead of dollar value, make more sense when we're doing this estimate, because this will give the top manager, when they make a decision where to allocate their team. Okay. So here for each task, and we spread out into the functionality, and we calculate how many total person months they need. So in this particular example, we have a total person months 46 person months. So if your average burden labor rate is about 8,000 a month, 8,000 a month is about $50 an hour. Is about if you do the calculation, 8,000 per month means around 2,000 per week. If each week you have 40 hours, so this one, the 8,000 is about $50. Yeah, $50 hourly rate, then it'll be around 8,000 per month. So the estimate cost, you have a 46 person month, and 1 month you pay 8,000, so it will be 46 times 8,000 will be 368,000. This is cost, this estimated cost of this project. Okay, let me so based on this, let me go to your lab. Okay, hold on. Go to your lab. Okay, go to your lab. So in your lab, I'm asking for. In the lab, I'm asking for 1 month. I'm asking 3 months and $1 million. $1 million. 3 months and $1 million. So this implies that in 1 month, you have 330,000 to spend. And in our previous example, I showed you that if the 8,000 a month is about $50, so so this 1 month, so let's see, for one person, if it's 8,000, 8,000 a month, and this is $50 an hour. $50 an hour. So this implies that here, if this developer is $50, if this is $50 an hour, then it's 8,000 a month. 8,000 a month. So you have 332,000 to expend. If everyone is 8,000, then your team, then how many people you have? Then for the team, you need 42 engineer. So how I get a 42 is 300k divided by 8k, and this is about 42. So this is about 42 staff. So in other words, if your average hourly rate is $50, your team, you need 42 team member. You need 42 team member. So if your average rate is 100 an hour, then this translates into 16k a month for one person. And if this is your average hourly rate, then you will need 21 staff. 21 staff. Okay. So basically, you will see that based on how much you pay for the engineer, and your team size can be different. So I'm asking you that the average hourly rate cannot be more than $100. So usually your hourly rate will be between 50 to 100. That's a reasonable hourly rate. So your team member will between 21 to 42 staff. Either way, your original team is not enough. Your original, you have only 8 team member, is not enough. You need to expand the team. You need to create more team members to how many? To 21 to 42. So the task, this task is kind of complicated. You need to expand your team, like a developer. You can have a developer 1, 2, 3, and you can give a name, the Jeff and Tom, and then assign their standard rate. And here you want to make sure nobody is overused. So every member. You want to assign 8 hours a day. You cannot assign then the two simultaneous tasks, and each one require like 8 hours. So then that person will be labeled as red. So this means this person has been overused. So in one word, you do not overuse your team. On the other hand, you need to assign them enough work to do. You can't just so that what you need to have is 21 to 42 full-time. Then you can expend this much money a month, a full-time. If some staff is half-time, means you do not assign them enough work to do, then you need more than this. Yeah, so this is the one. Every one of them is assigned 8 hours. Then you need 21 if the hourly rate is 100. Otherwise, if some of them is half time, then you need more than 21. So basically, that's a scenario. Okay. Let's see here. If I assign if here I have like a developer 1, developer 2 here, and each one I give like a I give 75. Yeah, this one is more senior. I can give 120. Yeah, 120 an hour. So average is still like average still about 100. Then I go to the Gantt chart. So when you assign resource, okay, you see that this task take 14 days. How I can increase the budget? Okay, so here you first I assign to more than one person. I assign this task to more than one person. But when you assign to more than one person, you will see this duration will be cut off. Proportionally. Yeah. Oh, yeah. This one is not. Oh, it's not changed. Okay. Yeah. Hold on. Let me see. This is not the case. This is the. Oh, here. Here we go. Yeah. Yeah. Oh, okay. Because here I apply to a category. That's not right because the duration won't change. When I apply to an individual task, for example, like this task is assigned to the analysis, and it takes 5 days. How increase analysis? Then I can assign to uh like a developer two as well. I assign to two-person. So here, initially take 5 days. If I assign to two-person, it will become 2.5 days. See that it become 2.5 days. So the budget remains almost the same. So even you increase one person, but duration goes down, and you multiply them two times, still the cost doesn't change. So you still go back to 5 days. Change to 5 days. So that's how you massage your cost. You massage your cost. You here for each task you assign to more than one person. So when you assign to more than one person, please keep in mind do not overuse them and do not less use them. Just you have to use them just right, so that everyone get a full-time job to do. And when you assign to more than one person, so here still keep your original date. Yes, still keep the original duration. So that's how. So you don't mess up the lab one, because your lab one you already have the start and the finish date, and this one is already set. You don't want to mess up what you already accomplished. So here keep the same duration but assign to more person. And the goal here is not to overuse, not to less use, to underuse anyone. Okay, so that's the lab two. I want you to massage your project planning to close to $1 million and 3 months. Okay. Okay, let's go back to here. The process based. The next one is the problem based estimation. Here we use a line of code or function point approaches. So here we're using the statistical approach involving the size. So here we use historical data to build estimate. If we have the historical data we have the relationship of line of code to the cost, then we can use the formula to calculate. So here we have the estimate of the size of each function of the software. Then we have the total line of code, total size of the software. This is what provided is historical data. The historical data shows the productivity. Average productivity for a system of this type is about 620 line of code per person month, and the burden labor rate is about 8,000 per month. It's about $50 an hour. So here give you the cost per line of code is about $13. It's $13. So if you're new product and you estimate the line of code is about 33,200, then you can easily calculate the dollar amount, how much it cost, and also you can estimate since you have your productivity is 620 line of code per person month, and the size of the new software of a new project is 33,200 line of code divided by productivity, then you know you need a 54 person months to finish the product. So here implies that if you have a 5-person, then you need about 10 months, and you have a 10-person, probably can finish in 5 months. So here the person months not just you can easily translate to the dollar value, and you know that how big the team size and and then you can estimate how long it take to finish the project. So the previous approach is using the line of code, and also you can use the function point. So function point is another way to calculate the measurement of the product size. People argue that the line of code can be quite a bias. If you use like the assembly language, the size can be really huge, but doesn't the larger size doesn't mean it's complicated or can implement a lot of functionality. So, but if you use a high-level language like Java, just one line of code, you may need like a 10 or 20, even 100 line of embedded code to implement. So here, the size is not. Sometimes people argue is not a fair. Is not a fair indication of how long how complicated the software is. But a function point, on the other hand, not considered like a line of code, and then use a different indicator to do that. So the function point is a measurement of the product size in terms of functionality that needs to be implemented. So here, eliminate the bias of the programming language you use. So here, once we have the function point, then we can use the same way in the line of code. We can use to estimate the cost, and we can use to predict. So whatever you can use for the line of code, you can use a function point as a replacement. So to calculate the function point, we need to first get the 5 domain characteristics. The first one is the number of external input, and the number of external output, number of external inquiry, number of internal logical file, and the number of external interface file. We need to get these 5 domain characteristics. So let's see them one by one. The external input are the user or another application originate input and provide distinct application-oriented data or control information. So here, inquiry are not considered as input. So inquiry, like you ask, you fill in some like the form and fill in the information, and then you click on submit. These kinds of things are called inquiry, are not input. External output is derived from the application and provided the information to the user, like the report, like the screen, like any error message or anything display, and is as a feedback to the user, consider external output. And the number of external inquiry is an online input results in the generation of some immediate software response in the form. So like you need to fill out the form, you need to click on some the menu items. That's all considered as external inquiry. Internal logic file is the data within the application, and the external interface file is the data outside the domain of the application. So this we have this inside the data. This including the database or like the intermediate file, the time file is all considered as the internal file, and the external file is something outside. Okay, then once we have these 5 domain metrics, then we can bring them into this table. Then for each input, then there's a 3 weighting weighting factors. Can be simple, average, and complex, and then they have a different weight. Then you multiply them, and then you add them up. You have this counted total. Yeah, the function point. And then once you have this the counted total, then you need to answer this 14 question we call the function point, the value adjustment factor. And for each of them, you give a 0 to 5. If the backup is required, 0 is no need to back up anything. And absolute, it means you must have a backup. So, answer this 14 question and give 1 to 5, 0 to 5 for each of them. Then we bring the total, the unadjusted total. So this total is from here. We bring into this formula. Bring into t, and this f is the 14 value adjustment factor. 14 factors. We add them up, and then times 0.01 and add 0.65, and then adding up and times this unadjusted function point from the table. And this is function point. So this is a function point we got. Okay, so from here you'll see that the function point actually looking pretty much, a lot of information into your project, not just some metrics, and also have some estimation. So some estimation. So by using the function point, you can have quite a good estimate of how complex of your software is. Let's look at one example here, and how we actually get that 5 domain value. So to get a domain value, we need to use the data diagram to do the analysis. So here, starting from the problem specification, the spell checker accepts a document file and an optional personal dictionary file. It lists all words not contained in either of these files, and the user can check the number of words processed and the number of spelling errors detected at any stage during process. So just based on the description of the problem, then we can draw the data diagram. So here we have the spell checker. Then we can looking at the what's inside and what's outside. So here the user will ask any error found and how many words processed. And so here in order to do that, the user will fit in the document file and the check and the personal dictionary, and also the spell checker has an internal dictionary. So basically the spell checker will combine the personal dictionary and the internal dictionary and then check against the document file to see if there's any spelling error, and count how many words processed. So in order for the user to feed this document file and the personal dictionary, and the user should provide the document file name and the path, and the same as the personal dictionary, the file name and the path, and in order for the spell checker to grab the file and do the analysis. And the spell checker, based on the description, will provide some report, like the number of word processed and number of error message, and the report on any misspelled the words. So I have a three report. And then we draw this data diagram and to represent the description. Then we can count these 5 domain characteristics. The first one: external input, external output, external inquiry, internal logic file, and external interface file. So can you tell me, also here I see the external input, there are 2 of them. So can you tell me which 2 of them are external input? The first impression come to your mind, you may consider this a document file and a personal dictionary file are external input. Actually, no. Yeah, the answer is no. Yeah, this two file are external interface file. External interface file. Yeah, so here we have two external interface files. So these two are actually external interface file. Then what are these two external input? These two input are actually the name and the passes of these two files. These are the input. These are the input into. So this is what you fit into the software, the spell checker, so that spell checker can grab these two files. So the document file name and the pass are external input. So external output, there's three of them, and this one is easy to understand. So these three message are three output. An external inquiry, there's two of them. So these are two, error founded and how many word processed. So these are the question. So these are the inquiry. These are two external inquiry. Internal logic file. That's one of them. So this is the internal document. I'm sorry, internal dictionary. These are internal logic file. So this is in your meeting exam, I will and you will face similar problem. So I will give you the problem specification, the problem description. I will ask you to draw a similar data diagram, and then from here you identify how many this domain value. And after you have this, you bring them into this table and apply weight to each of them. So in here, I will specify the weight number you use. Your job is to count how many of them for each domain value, and I will specify the weight so that you can calculate the unadjusted function point. Once you calculate the unadjusted function point, so here the next thing is to calculate the value adjusted factor, 14 of them. So I'm not going to ask you to specify the value. So I will just tell you like the total. Yeah, so that you just bring this total and what you have in here into this formula, and calculate the function point. Okay, then just similar to our previous example, we use the line of code. So here we use function point. We still have the historical data. The average productivity in terms of function point is 6.5 function point per person month, and the labor rate remain the same. And then we can we know the cost we can calculate the cost per function point is $1,230 per function point. So the total estimate cost is the unit price of the function point times how many function points you have. So you have your value, and also you can calculate how many person months you need. 64 divided by productivity. So you have a 10 person months to finish the product. So if you have a 5 person, probably can finish in 2 months, and 2 person you may need 5 months. So this is how we can make an adjustment here. So these two are similarly function point and line of code. They follow the same path, but the function point obviously is more complicated. You need do analysis of problem, and then get this domain value and fill in this value and adjustment factor. Then you can calculate the function point. Then use the same way as line of code. So this let's working on this class exercise. So in here, instead, so in this problem, you'll see that you have 8 simple input, 1 average input, and 9 complex input. In our previous example, all input using the same weight, either simple or average or complex, but in reality, some input can be simple and some can be average and some can be complex. So this example will practice that. So in here you have 8 simple input. It will be 8 times 3, and then plus 1 average, 1 times 4, then plus line complex plus line times 6. So here you add them up. So you have this dot product, and then you have this unadjusted value for external input. So similarly for external output. So this practice showing you that you don't have to use one weighting factor for all domain values. Can be different. Yeah, you can have. Okay, the next method we will introduce is the Cockman. The Cockman stands for constructive cost model, and it's introduced by the Barry Bean, and he's a professor in South Florida. When he introduced this Cockman method, but now I think he changed his to another university, and I didn't follow. But I know that he was used to be a South in California, and one of his students used to be my colleague when I worked in Motorola. That's back to 2001. That's 19 years ago. Yeah, his student worked with me. Yeah. Okay, so this Cockman model is basically it is a static method. It's a static method, and what I will introduce here is the Cockman 1, and nowadays people using the Cockman 2, but idea behind is the same. The Cockman 2 is just a more sophisticated way. But fundamentally it's still a statical approach. Yeah, it's just using more factor, more calibration, but behind idea is the same. Yeah, by using the size. So Cockman model will predict the effort and the schedule for software product based on the size and a number of cost driver that will affect the productivity of the team. So that will combine the size and the cost driver together and make estimate. So from here you see the basic values here is still the size of the product. This three model reflect complexity: the basic model, intermediate model, and the detailed model. So here we only introduce the basic model and the intermediate model. The basic model consider size only. Intermediate model will consider cost drivers, and the detailed model is an intermediate model, but used in different phases of the project. And then for each model, this different project characteristics. So here we have 3 levels. One is organic. Yeah, so what simple small project is an organic mode, and the embedded mode is the project is tight and inflexible in time, and need a great innovation. And so here we call it embedded. And if you are not sure, then you may use a semi-detached. It's something between the very simple and the very complex project. So there's something feel in between. So we have three mode for each model. The equation taking the form of A times SB times A raised to B times M. So in here, A and B are factored based on the project type and the complexity. So there's a table. So I'm not asking you to memorize the table. If this Cockman appear in your exam, I will provide that table, specify the A and the B, But you must understand the table. You know that which formula to use and which A and B to choose. And here's S is a size, is a product size in K delivered source instruction. So it's KDSI or K line code. So if I say if line code is 1000 and this S is 1, it's not 1000, it's 1. A and B depend on the project mode and the type. So here shows you the table choosing different A and B. For the basic model, intermediate, so you don't see based on is basic model or intermediate model, A and B is different, and then we have a different mode of this one for simple product, for simple project, and embedded for very complicated one, and A and B take a different value, and then semi-detached something in between. So here, depending on what is a basic model or intermediate model and different mode, then you can choose different A and B. This is a again, this table will provided. If this problem appear in your exam, I will give you this table. You don't have to memorize it. Oh yeah, for your exam is a take home exam anyways. Then you can then you will have access to this table. Cost driver. This one only apply to intermediate model. In the basic model, since what you need, so consider basic model is used in the earlier phase. You don't have much detail, insight into your product, so you don't have you don't have this cost driver information. You only know the size, but you still can do some estimation. So the intermediate model will consider not just the size, but this meaning cost driver. Cost driver for each of them. For cost driver, there are 4 categories. For the product attribute, the computer attribute, the personnel attribute, and the project attribute. So there's a 4 category, and there are total 3, 4, 5. Yes, 3, 4, 12. 15. The total 15 cost driver. Each of them you give a rating from very low to actual high. And if you don't have much information about them, you just use 1, so they don't contribute to the cost driver. So 1 is a nominal. So actually, your basic model, you consider M is 1. M is 1 means everything you put in nominal, the middle point. But once in the intermediate model, you know more detail, like the required reliability is very high, and database size is low or high. So then you know more information. Then this M is not a 1 anymore. The M here is you multiply all 15 cost driver together. So if all of them are 1, when you multiply them, it's still 1. But if one of them is not 1, then the product M is not a 1 anymore. It's either tier is either to the left less than 1, or to the right is more than 1. So this is how you twist you can have this final product. Okay, so basic model M is 1, and intermediate model M is not 1. So as I mentioned before in the last slides, so the basic model we only use a single predictor variable. So here we use this one in the earlier phase. Let's look at the equation. Okay, so for the basic model, we have 2 equations. So taking different A and B. So this E is effort. And then we can also calculate the schedule. Yeah, so we can have these 2 formula. One is to calculate the man months, and then we can also have we also know how long it take for this kind of project, how long it take to finish. Let's look at the one example here. So we have determined our project fit the category of semi-detached mode. Then semi-detached mode, we use these 2 equations. And we estimate our project will have 32,000 delivered source instruction. So we know this KDSI, this KDSI is 32. Using the formula here, we bring to the second equation 3.0 times KDSI 32 and 1.12. Then we know. So here you need a calculator. Okay, you need a calculator to do that. And it's 146 per month. And then we can also calculate the schedule, bring the E into this equation 2.5 times 146 raised to 0.35 is 14 months. 14 months. Then we can further do the productivity for this kind of project. 32,000 DSI divided by how many person months. So here the average productivity is 219 DSI per person month, per man month. Further, we can calculate the average staffing. Is your 146 person months, and you need 14 months to finish. Then you need 10 full-time. The FSP is a full-time equipment software engineer. So you need 10 people, working full-time to finish the project in 14 months. So from here you see that why Kokomo model is popular is because it will give you a set of information. It's not just an effort. Not just effort, it will also give you in industry like average a schedule. You can know the average productivity and how big is your team is. So this contains a lot of information. So that's why this Kokomo model is popular. People use this one as a benchmark to organize and not just to estimation. You can use this one to organize your team. So here I want you to working on this exercise. So because this this exercise you are supposed to finish this one in 5 to 10 minutes. 5 to 10 minutes to finish it. So I'm not going to wait 5 minutes for you to finish. So I will just go directly to the answer. To the solution. So when you do it, please pause the video and spend like 5 minutes. If you can finish in 5 minutes, then you are in good shape. Okay. So similarly, I said it. So we have a determined project is simple mode. Simple. Then we use organic mode. We use this formula set, the first two formula, and then we estimate the project have 5,000. So this KDSI is 5. Then you can calculate the effort. 2.4 times 5 raised to 1.05 is 30 man months. The schedule, bring the E to the equation 2, and then we got 6.7 months. Productivity and average staffing. So in your exam, if a model appears, I will ask you to calculate this for effort, schedule, productivity, average staffing. So this is the basic model. Intermediate model is just an extension of the basic model. Just consider these 4 areas of the cost driver: product itself, computer, personnel, and project. So there's 15 of them, 15 attributes, and each attribute take from a very low to actual high. If I don't mention this particular cost driver, you just consider that cost driver to be nominal. Just take a value 1. Okay. And again, in here, the formula is similar still, 3 different modes, and then we can calculate effort and schedule. The only difference is for the effort, we consider this M. This is a cost driver. This M is not 1 anymore, so we'll take some value in here. So the intermediate model is when we gain more information, then we can use the intermediate model. Then let's look at an example here. So project A is to be 32,000 DSI and semi-detached. I tell you the mode, and it is in a mission critical area, so the reliability is high. So here, in the past, we consider everything equal 1, but in here the reliability is high. When you check that table, when you look up into the table, you see that when reliability is high, this reliability is 1.15. Then the M, since I don't mention other cost factor, so you cost driver, you consider the rest of them. The rest of 14 are all 1. Only reliability is 1.15. So this M is 1.15. So here you have effort, schedule, same, productivity, and the average staffing. Okay. Then let's look at this exercise. So for this exercise, you still like if you can finish in 5 minutes, you are in good shape. So it's an embedded software module of an aircraft. Aircraft is predicted to have a 15,000 line of code. And what's the development effort needed if the software module has high complexity, high execution time stream, very high reliability, and will be developed using very limited software tools. How many people are needed for the project using the intermediate COCOMO 1? So in here, we see we are going to use let me see, the submodule is pretty okay, this one it doesn't mention, it's embedded software, so we're going to use the embedded. We're going to embedded mode, so we are going to use these two formula, embedded mode, and this KDSI is 15, and then then next is to determine what is M. What is M here? So from here we see that the module has high complexity. So you're looking at the product complexity is high. Then you look up the table high is 1.15. Productivity complexity is 1.15. And the high execution constraint. Execution time constraint is belong to computer attribute. So this one is also high. If you're looking at is 1.11. So you're going to use 1.11. And the very high reliability. So reliability is very high, so it's 1.4. And will be using very limited software tool. So using a tool is very low. No, it's very low. Okay, it's very limited with very low. So this one will take 1.24. So let's see. Looking at the table here, we are going to take very high reliability, very high 1.4, and high complexity 1.15, and the high execution time constraint 1.11, and very low use of tool 1.24. You multiply them together. Yeah, you multiply this M. You see this 4M together. You have the M, you have the E, so you bring into the formula and do the calculation. Okay, so for the rest of them are quite even you know which formula to choose, and you connect the description of the cost driver into this table and choose the right value and bring into the M, and then you just use the formula to do the cost estimation schedule, and then you can derive the productivity and how many people you need for the team. So this similar problem will appear in your telling you will appear in your exam. Okay, I think that's it for today. So for this week's lab, as I mentioned, you need to add in more people in here. How many people to add? You need to based on how many the hourly rate. You need 22 to 41, 22 to 42 staff, and then you need to go to this Gantt chart and then assign the task to more than one person will keep the same duration of the task. Then you can increase your budget. And so basically I want everyone is just using right, not overuse, not underuse, and they have to be a full time so that when you show me this resource nobody in red corner, in red color. Yeah, so okay, so if you have any question, please come to my office hour.